Hey everyone, and welcome back to Space Up. Today we're talking about our very own star, the Sun. It might seem like a calm, steady presence up there, but recently, it's been throwing some serious tantrums. And trust me, when a star that holds 99.8% of the entire solar system's mass gets a little grumpy, we on Earth need to pay attention. Over the past few weeks, observatories and satellites pointed at the Sun have captured some absolutely jaw-dropping events. We're talking about massive solar flares and something called coronal mass ejections, or CMEs. Picture this: explosions of pure energy, so powerful they dwarf anything we could ever create, bursting from the Sun's surface. These events are capable of launching billions of tons of superheated plasma, the very stuff stars are made of, out into space, hurtling towards us at millions of miles per hour. It's like the Sun is firing a cosmic cannonball, and sometimes Earth is right in the crosshairs. Now, a little bit of solar drama is normal. The Sun goes through an 11-year cycle of activity, moving from a quiet period, called the solar minimum, to a chaotic peak, the solar maximum. During the maximum, the Sun's magnetic field gets tangled up and eventually flips its north and south poles. It's a messy, energetic process that leads to more sunspots, more flares, and more CMEs. Here's the kicker, though, the part that has scientists scratching their heads. We're not supposed to be at the peak yet. According to all the predictions, the next solar maximum isn't due for another year or two, around 2025. But the Sun, it seems, has decided to rip up the schedule and throw its own party early. Recent data coming in from NASA and the European Space Agency is showing that the number of sunspots, those dark, cooler patches on the Sun's surface that are hotbeds of magnetic activity, is already more than double what the official forecasts predicted for this time. It's like a volcano that's supposed to be dormant suddenly starting to rumble and spew smoke. The big question everyone is asking is, why is this happening? Is this just a temporary surge? Or are we heading into a solar maximum that's far more powerful than we anticipated? The truth is, we don't know for sure, and that uncertainty is both thrilling and a little bit terrifying. So, why should we, down here on our little blue marble, care about the Sun's mood swings? Because when these cosmic storms of charged particles reach Earth, they interact with our planet's own magnetic field, creating what's known as a geomagnetic storm. On the beautiful side, these storms are the reason we get to see the Aurora borealis and Aurora australis. The particles from the Sun slam into our atmosphere, energizing atoms of oxygen and nitrogen, which then release that energy as breathtaking curtains of green, pink, and purple light dancing across the night sky. Thanks to this recent surge in activity, people have been spotting auroras in places they're almost never seen, all across the United States, the UK, and even further south. It's a spectacular celestial light show, courtesy of our star. But there's a darker side to these geomagnetic storms. Our modern civilization is incredibly, fragilely dependent on technology, and that technology is extremely vulnerable to what the Sun can throw at us. A powerful geomagnetic storm can induce electrical currents in long conductors on the ground. What does that mean in practice? It means it can overload and fry transformers in our power grids, potentially causing widespread, long-lasting blackouts. Imagine entire cities or even countries without power for days, weeks, or even months. The knock-on effects would be catastrophic. No clean water, no refrigeration, no communication, no financial transactions. And it doesn't stop there. The satellites orbiting our planet, which we rely on for GPS, television, weather forecasting, and global communications, are directly in the line of fire. The flood of radiation can damage their sensitive electronics, effectively turning these billion-dollar pieces of technology into space junk. It could disrupt airplane navigation systems, forcing flights to be rerouted or grounded. Even the internet, which we think of as this ethereal cloud, is dependent on a vast network of undersea cables that could be affected by these induced currents. To understand the real potential for disaster, we have to look back in history. In 1859, the world experienced the most powerful geomagnetic storm ever recorded, the Carrington event. It was named after Richard Carrington, an English amateur astronomer who was sketching sunspots when he witnessed a white light flare erupt from the sun. Just 17 hours later, the storm hit Earth. In the 19th century, our most advanced technology was the telegraph. The storm was so intense that it induced currents in telegraph wires that were powerful enough to shock operators and even set telegraph paper on fire. Auroras were seen as far south as Cuba and Hawaii. People in the Rocky Mountains woke up in the middle of the night, thinking it was dawn because the sky was so bright. Now, imagine an event of that magnitude happening today. Our world is 1,000,000 times more technologically interconnected than it was in 1859. A study by Lloyd's of London estimated that a modern Carrington-level event could cause trillions of dollars in damage. It could shut down global supply chains, cripple financial markets, and lead to a technological blackout that could take years to recover from. We're not talking about a sci-fi movie plot. We're talking about a very real, high-impact, low-probability threat that governments and scientists are taking very, very seriously. But it's not all doom and gloom. This early awakening is also an incredible scientific opportunity. We have an entire fleet of spacecraft studying the sun like never before. There's the Solar Orbiter, a joint mission between ESA and NASA, which is taking the closest ever pictures of the sun and flying over its poles for the first time. Then there's the Parker Solar Probe, a true daredevil of a spacecraft. It's literally flying through the sun's outer atmosphere. The corona, enduring temperatures hot enough to melt steel to touch the sun and sample its particles and magnetic fields directly. It's like trying to study a hurricane by flying a plane right into the eye of the storm. The data these missions are sending back is revolutionizing our understanding of how our star works. By studying this unexpected surge in activity up close, scientists hope to improve their models and get better at predicting so-called space weather. Just like we have meteorologists forecasting hurricanes and tornadoes on Earth, space weather forecasters are working around the clock at places like NOAA's Space Weather Prediction Center, trying to give us early warnings of incoming solar storms. An advance warning of even just a few hours could give power grid operators time to protect their systems, and satellite operators a chance to put their spacecraft into a safe mode, potentially saving us from the worst-case scenarios. So, as our star flexes its muscles and puts on this incredible fiery show, it's a powerful reminder of our place in the cosmos. We live at the mercy of a giant nuclear fusion reactor 93 million miles away. It gives us life, warmth, and light, but it also has the power to unleash unimaginable chaos. The sun is reminding us who is truly the boss in this solar system. And as this solar cycle continues to ramp up towards its unpredictable peak, one thing is for sure: the show is just getting started. We'll be watching closely, bringing you all the latest updates as our star continues to awaken. Thanks so much for joining me today on Space Up. If you found this journey into the heart of our sun as fascinating as I did, make sure to hit that like button, and if you haven't already, subscribe and ring the bell so you don't miss our next cosmic adventure. Stay curious and look up.